Hello, welcome. So this brief lesson is going to cover nth roots, and the first thing we're going to talk about is the list of perfect squares and perfect cubes. And briefly, a perfect square is a number that is multiplied itself so that it'll give you the product of a number where you can take the square root of it. So 2, if you multiply 2 itself twice, 2 times 2 gives you the product of 4. If you take the square root of that product, you get 2 back. You get that number back. So the square root of 9 is 3, square root of 16 is 4, square root of 25 is 5, etc., etc. The same thing goes for perfect cubes. Instead of a number multiplying itself twice, it's going to be multiplied itself 3 times. So 1 times 1 times 1 is 1, and when you take the cube root of 1, you get 1. Cube root of 8 is 2, because 2 times 2 times 2 gives you a product of 8. The cube root of 27 is 3, so that when you take 3 times itself 3 times, you will get 27. Take the cube root of 27, and you get 3 back. And the same for the rest of the perfect cubes. Then, of course, this pattern repeats for the next highest root, which is the fourth root. So the fourth root of 1 is 1, because you got 1 times 1 times 1 times 1 4 times, and you get 1. Same thing with 16. The fourth root of 16 is 2. If you take 2 and multiply itself 4 times, you will get 16. 81, fourth root of 81 is 3. Take 3 times itself 4 times, you'll get 81. So as you can see, this pattern repeats for the next fourth root. And then the list of fifth roots is very similar concept, right? Times a number 5 times, and then you get that number. So when you take the fifth root of that number, you get that number back. Okay, so fifth root of 1 is 1, fifth root of 32 is 2. Multiply itself 5 times, and you get 32 back. Fifth root of 243 is 3, and then of course this root here, fifth root of 1224 is 4. We rarely use those really high numbers. The fifth root of 32 and 243 are very commonly used. So very rarely you're going to use numbers that go really high. Okay, you usually have a calculator to do that for you. Alright, so let's do a few examples of nth roots, simplifying nth roots. Okay, so again, we're going to simplify. Sorry about that. Okay. Alright, so the first example is, let's say you had the cube root of negative 8. Alright. So the cube root of negative 8 would be negative 2. And you're probably saying, why? Well, 2 times 2 times 2 is 8, and then when you multiply 3 negatives, you still get a negative. Okay, so we got to remember that here, this is what this really means, right? An odd number of negatives will give you a negative. All right, so the answer is negative 2. The next one, okay, let's see if we have, okay, let me write this down. Alright, so let's see what this is. Alright, so we want to take the fifth root of 32. Remember, the fifth root of 32, if you go back here, fifth root of 32 is going to be 2, right? So we go back. Alright, so remember, the negative stays on the outside. The fifth root of 32 would be 2. Now we got to be careful, because we're taking a number, right? We're taking negative 2 times negative 2 times negative 2 times negative 2. We know 2 times 2 times 2 times 2 times 2 is 32. And if you multiply an odd number of negatives, which will be 5, will give you a negative 2 back. And then, of course, if you multiply if you multiply the two negatives, okay, you will in fact get a positive 2. So you're going to be really careful with the negative signs. When you have an odd number of negatives, okay, you'll always get a negative product, okay? If you have an even number of negatives, it will always turn into a positive number. All right, so let's do trying to think of ones that are okay. I have one for you. I'm trying to think of ones that are not too obvious. Sorry, 3. Okay, so what we got to remember is that let me just mention something. So if you have something like this, let's say you had, okay, we're going to talk about rational exponents for a minute. Why do I want to mention this? Okay, well, if you have something like this, if you have a quantity raised to a fractional exponent, an equivalent way of writing that, okay, is that the denominator in the rational exponent is going to be the root, and then the numerator of the fraction is going to be the exponent. Okay, so you're probably why, what does that really mean? And by the way, the x goes here. Okay, so if you have this example in the bottom, cube root of negative 12, if you remember the order of operations, we want to do what's inside the parentheses first, then you do the exponents. So if you take the cube root of negative 12, okay, we're not really going to get an answer other than, no, we're going to get a perfect cube is what I'm saying. So we're probably going to have to split this up into a product of 2 radical cubes, so one's a perfect cube. So let me think here. Okay, so let me just make sure it's the right color. Actually, you know what? We're not be able to do that actually. No, because the product of no, we're not gonna be able to do that. Okay, I'm not sure what I was why to do that. So okay, so normally if this was a perfect cube, you can do that. So instead we're going to rewrite this using a rational exponent form. So we're going to write down as, let's see, negative 12. We're going to raise that, since both the root and the exponent are the same, it's going to be 3 over 3, which equals negative 12 to the first power, which in fact equals negative 12. Right? Anything to that first power is going to be that base, the same base, right? Okay, so let's do this one. Okay, so let's rewrite it using rational exponent. And don't forget, this is going to be the exponent is the numerator, the root is the denominator. So this is going to be 6 reduced to fraction, 6 divided by 3 is 2. Okay, and the answer is going to be 144. Okay, negative 144, or positive 144, sorry. Okay, so, yeah, okay. So positive 144. That's your answer. All right, so let's go to the next page. There's a little more room. Okay, I believe this was the fifth one. Let's go ahead and simplify. Sixth root of negative 64. All right, what's the answer to this? Well, think about it. The sixth root means we're going to multiply a negative number by itself 6 times. But if you remember, this is an even number of negatives, which will always give you a positive result. We're trying to take the sixth root of a negative integer. That cannot happen because if you take 6 negatives and you times them, you will get a negative, you will get a positive answer, and this is certainly not positive. So this is going to be undefined. Okay? All right? And the reason is because, think about it, if you have 6 negatives, whoops. Okay, 6 negatives. That's going to give you a positive result. Okay, so that can never happen. All right, so it's going to be undefined. Okay, all right. So okay, let's do this one. This is a good one. Okay, what do you think this one is? All right, so the fourth root of negative 1. Okay, again, look at the exponent. That's even. We cannot multiply 4 negatives and get a negative answer, right? So you don't even have to figure out the fourth root. I mean, you can't, it's just going to be 1, but, 1 times itself 4 times is 1. That's not a problem, but 4 negative ones? Nope, it's going to give you a positive answer. So that's not going to work. All right, so the answer for this is going to be another undefined. All right, so I hope you guys are catching the hang of this. Okay. All right, so let's see. Let's try this one. So that's the sixth root. Okay. Okay, how would you handle that? Well, we write it in rational exponent form, right? So x is what's inside the radical is the base, and we're going to raise that. The exponent is the numerator, and then the root here is 6. It's kind of like the opposite. Now, 24 divided by 6 is going to be 4. Okay, and x to the 4th power, okay, would be your answer. Okay, does that make sense? All right, so hopefully you started getting the hang of this a little bit. All right, so it might be helpful to list the perfect roots, before you start this. Let's do one more for the road. Okay, so we write this in rational exponent form. 2 20 divided by 4. All right, so that becomes 2 to the 5, 2 to the 5th power, I mean. Okay, and now we're going to get 32. 2 to the 5th power is 2 times 2 times 2 times 2. That's going to equal 32, and that would be your answer for that. All right, so you kind of have to realize that we're going to, if you go back to here, rational exponents will help you simplify nth roots by changing the format. Okay, so, and this kind of go vice versa. You know, if you have right, you can go back the other way, right? You can write this here, and then we're going to flip the. So basically, what this means is that. Okay, so if you look at it this way, I guess for this part, you know, a is the exponent. Okay, and b is the root. Okay, so for the top one, a in the numerator represents the exponent, and b in the denominator of that fraction represents the root. Vice versa here. B represents the root, and then A represents the exponent. Okay, so it's kind of important to maybe comprehend this format. All right. Okay, so that concludes a brief lesson on nth roots. I hope this was very helpful to you. Thank you for watching.